Hello everyone, thanks for joining. My name is Randy D'Souza. I'm a solutions engineer from Akamai Technologies, and again I'm going to talk with you today about an overview of our partnership with Cisco and how we're bringing Akamai technology into the branch by way of Cisco. So, to start you guys off with there, how many of you are familiar with Akamai? Yes, no?
No, I don't.
Okay, so...
I'm a storage guy, I don't get this networking stuff.
No, not at all. Not at all. So essentially, Akamai is a distributed cloud platform that is throughout the world. We have 150,000 servers scattered around, all interlinked together. And the more important piece of that, we're in about close to 1,500 networks. So the point of it is that we're very close to all of the world's internet end users. And we are in all these networks, so we can be within one network hop of most of the internet. So how does this tie into Cisco? So we notice that there is a huge growth of application support that's going over HTTP. I'm sure you guys have seen this in your professional lives, and the explosion is very hard to tame. So as a result, we wanted to be able to optimize performance at the branch without having companies consistently throw money at the situation. So we're going to bring HTTP caching into the scenario. So just to give you guys an understanding of where this business impact comes into play, if you've ever been in a store or perhaps at a remote office for your respective roles, you'll find that internet connectivity can be slow and or painful, and in the back end it's typically going to be expensive. If you're on your mobile device, if you notice you're on, say, an e-commerce website, and you see it takes a long time to respond, you're typically going to move away and say, all right, you know, the heck with this, I don't want to deal with it. So we wanted to be able to bring that user experience to be able to have a quick response. So just give you guys a brief overview of what Akamai looks like today on our core side of business products. We have this distribution here. Here are some of the numbers. I'm not going to go into too much detail for time restraints, but just to give you guys an idea of some of the pieces that entails. So this is how it looks like today. This is going to be part of the WAN technology, in particular the application performance space, where we sit on a WAS appliance in the branch, and it's part of the latest code that's available today for WAS within the Intelligent WAN platform.
So this is shipping?
This is shipping today. It went FCS August. So it's been about a month and a half, something like that. So it's available today. In terms of where it sits into the mechanism and the conversation of Intelligent WAN today, we're in the application control place, and that's where we want to bring this performance, these aspects into play, where, again, we're going to take our core competencies from Akamai in HTTP caching and bring it into the branch. We're able to take this optimization and about 15 years of experience from using internet caching and bringing it back there, so we can now optimize that experience regardless of the connectivity point.
So this is effectively an HTTP cache sitting on an ISR.
That is correct.
Okay.
That is correct. So you're familiar with some of the already existing architectures today and acceleration. Some other vendors do them. This is taking it to a whole nother class of performance. And I'll show you some results that we got from our beta phase, testing us out with some of our valued customers who helped us out the first half of 2014.
So your value add is effectively that you know what to cache.
That's exactly correct. He's right on. I like him.
This guy is good.
Seems like real value to me.
Yeah, sure.
Exactly. We're essentially analyzing the situation and saying, okay, this is going to be perhaps redundant HTTP objects, and therefore we don't have to constantly go back to a web server to request them time and again, time and again.
No, but if someone would ask you what's the difference between you and Squid,
okay,
the idea is that you know what to cache.
Exactly. Squid is more going to be a dumb open source appliance. We're just adding a lot of intelligence into it. So
I take that personally. Just saying.
Well, he said that.
Your words, not mine.
So what we're looking to do here is offload from these branches and increase performance in doing so. So think.
Can I push content?
No, this is, well, hold that thought. The short answer is that we're going to cache content that comes at a request from the end users that are leveraging the branch. So say you're at a remote office somewhere and you're on X website and you say, oh, I want to go visit this page, you're requesting that content. Now,
But if I'm in the corporate data center and I just put up a new version of the self-service HR portal, I'd like to be able to say, push this to all the branches at 4 o'clock in the morning. So
Or publish a video.
oh, okay. So I was going to talk about this a little later, but this is an excellent segue. One of the features of this software
Just a
is
storage guy.
just a storage guy. What?
Web pages. Right?
Exactly. That's why I understand it. It's storage.
One of the features is this: you can warm the cache, or what we call pre-positioning, and you can request specific.
That's what I meant. Yeah.
Exactly. So it's an overlaying feature that leverages all the caching mechanisms. There are 3, and it can say, okay, these 3 features, I want to essentially schedule when I want that to come in.
You know,
And
Larry Ellison did a keynote, and every branch office of Oracle should have that video because Larry's going to demand that it be running on the video screen in the lobby 2 days from now anyway.
Exactly.
it's as if you wrote the script for this presentation because that's one of the exact use cases that plays in there. Quite literally.
Well, everybody knows Larry, isn't he?
Just a little.
So going into it, what we're looking to do is more into your generic internet capabilities, your intranet, so your internal applications that are perhaps being backhauled to a data center appliance. Again, in the context of WAS, you have a branch location, and then you have a data center location. It applies security there, as Matt talked about earlier on, within the context of intelligent WAN. And like I said, we can also talk about HTTPS connectivity there. So this is going to be handled as WAS handles it today, where the certificates are loaded on the data center head end, and that terminates the SSL connectivity point, and then we can see the headers. That's a very short answer. And that's what we want to be able to get the intelligence from, when we can see that.
Effectively, you have to download your certificates into the devices.
It's as if how WAS handles it today. Yeah, you load those certificates owned by the company, and we're all good.
Man-in-the-middle attack.
No, that would never happen.
So one of the other things that we can do for offload and adding performance, we talked about it beforehand, is generic internet connectivity. So say you're, again, at a branch or at a retail store and you have your own internet service provider. You're not backhauling it through a data center. Not a problem. You can still request that HTTP connectivity, and you're still able to optimize, still able to cache those objects. So one of the things I wanted to show you here for a compelling story is what we saw in beta. And this is something that we talk a lot about with our customers, and showing you the class of performance that we provide. So again, we talked about accelerating applications that are already out in the market, and WAS today does a really good job of that. This is taking it a whole step farther. So some of the things that we wanted to do was get a wide range of customers in different industries and how they would use this. We gave them some direction about how they want to optimize HTTP connectivity, and then said, okay, test it for us, tell us what you think, what we're doing well, what we're not, and so forth. So as you can see here, we have some pretty compelling numbers all across the board. We have an educational provider, a retailer, energy, and an MSP that was based out of Europe. And in all of those, we saw the important thing that I really liked was the reduction of latency. One of the major things that we often tout about is that you may have a great connectivity point from an internet perspective. The world is laying out fiber all around. That's just the way things are going. We want faster connectivity points, and we want immediate gratification when we're connecting to the web in all walks of life. And that still doesn't solve your last mile problem, right? You may have that connectivity, but you may still have the latency there, and that's what we're trying to resolve. Rather than having to go out over the public internet, why don't you just cache it right there at the branch so you don't have to make that jump, regardless of how efficient or not it is.
Are you doing anything like look-ahead caching, or are you doing that on the apps side? So you're looking to links from pages and trying to pre-cache those assuming you're not already saturated with direct requests from clients or anything like that? Or is it just saying when you ask for it, I've either got it or I don't?
That's right. So when you ask for it, it's going to see if it's in cache already. If it's not, then it would make a request out. Now, having said that, one of the features of the caching mechanism that I haven't talked about is that we can leverage the Akamai Intelligent Platform. So we have a core competency of having very smart decisions about what we can cache on the public internet. So we deliver a great deal of the world's business traffic today. Many vendors. And so and as a result of that, we built up a repository of intelligence about what we are and what we can and cannot cache. We've also devised some advanced rules as a result of that. So there are some objects there that are typically uncacheable that we can go leverage our platform and say, do we have some rule sets here, and then be able to pass that down into the branch.
The prefetch would improve user performance, but also increase network consumption. And they're trying to solve both problems at the same time.
Right.
Exactly, it's a compromise.
Yeah.
So you don't prefetch.
Well, it depends on what do you mean. What's your definition of prefetch? Let me ask you that.
That's a good one.
I loaded page A. Page A has 7 buttons on it, which links
Exactly.
to pages B1 through 7. You go, oh, there's 7 links here. Let me preload those 7 pages. So that he's going to want one of the 7.
But that's almost a browser function, right? No browsers do that in the background, which would...
Well, yeah, that's exactly the question. Are they parsing HTML and figuring out the links and downloading the potential extra content? Or are they waiting for browser to do the loading or preloading?
So the way it's going to work with the prepositioning function is that we provide a particular URL, and from within there, you can actually have a recursive function to scope down the links that are provided in that URL. So you say you went to, I don't know, e-commerce site.com/shoes. And then in that shoes department, you wanted to sort by color, or you wanted to sort, and then below that you may have another subcategory of leather shoes versus cloth, and so on and so forth. Any descriptive function there, and you wanted to download all of the content in those subcategories, you can actually provide a recursion depth of how much you want to preposition there. So if there are hundreds or thousands of objects below that, you have the ability to provide that request.
But that's the out-of-band management. I'm saying prefetch these 3.
As long as you provide a specific URL, not a problem. In one of the main use case that we want to strive for there within this prepositioning piece is to provide, say, large HTTP objects that normally would take a long time to bring in. So say rich media, high definition videos that have a particular URL, that's what we want to preposition. You bring it into the branch rather than having all of your users trying to request all that content going out over the public internet at the same time. That's going to create quite the congestion in the highway for information. So to give you some perspective on what is without WAS today, with WAS and then WAS with Akamai Connect. So we have a couple different use cases here from a mobile assisted selling prospect from one of our beta customers. And you see on the first category that without any optimization whatsoever, it took close to a minute. And if any of you have been in that situation,
That is cold cache on the browser.
that is cold cache. Yeah, you have no browser cache, you have nothing. Typically speaking, you're probably not going to wait a minute for a web page to respond. That's just the way the world works today and what we've grown used to. Okay. The second, first cache hit, you were going back to this gentleman's suggestion earlier. Say you're on your smartphone and you go to a website and you request some page and has objects on there, and it's being optimized by, say, WAS today. Okay, 18 seconds. That's from a nominal perspective, that's a tremendous improvement from 57. But from a user perspective, that's still not acceptable. You're going to wait 18 seconds for a page to respond?
That's still with cold cache on the browser.
Yeah, but now you're actually bringing the HTTP content within cache. So then we get into the second hit. So one of your colleagues, a friend of yours, goes to request that same content. 2 seconds. That's a little bit more manageable. That's a little bit more what we're used to.
But this is still with cold cache on the browser.
No. So yes. In fact, when we test this, we actually disable browser cache altogether.
Yeah. So effectively, I would get the same numbers, more or less, if I would visit that same application the second time in the day without your product.
That's right.
Okay.
On the same browser.
Of course.
Yeah.
Yeah.
On the same iPad.
Yeah.
That's right.
Okay.
But the fifth user in that remote office would be faster with this.
Yeah, sure.
And that's the main capability. And what we're trying to drive home here is that this is the world that we experience today, and this is what we're trying to strive for without having to increase bandwidth costs. And that's, I believe the previous gentleman mentioned that the world's IT infrastructure for any company is only going down. You're not getting more money to spend on bandwidth. You have to do more while getting less to spend it on. How am I doing on time? I know I probably run a bit over. Do you guys have any questions so far? I think I covered everything in a succinct manner as possible.
How much caching do you do? So how much memory do you have there?
It depends on the WAS platform that's presented, and it is categorized by what is available from that particular disk cache. Typically, we would consult our counterparts, the sales team, and they would be able to tell you an exact number for, I don't know, 4451 and how much available cache is there.
So it effectively depends on how much disk I put into the ISR.
Right.
So is this running natively on the ISR chassis, or is this on like a UCSC blade?
That's right. So in order for this to run, it needs a compute. So it's going to run on 2911 appliances and above, and the reason for that is, to your point, it needs either a UCSE or SRE, some sort of compute. 4451, as Matt talked about beforehand, has that capability built in. Yes?
Actually, it could run natively also on the platform. So with the 4000 architecture, you could run WAS as a container service. And Akamai could be coupled with that.
That was what I was wondering, if that was whether that was
right. So both the modes are supported, the container service as well as the UCSC compute.
Yeah, there's fundamentally no difference between WAS in a virtual machine on UCSE, WAS running on a 4400, 4300, or WAS running on an appliance. That's not true with the ISRG2s when we had WAS Express, which was a very pared down, lightweight version of WAS running natively on the system. But with ISR WAS on the 4Ks, it's exactly the same as WAS in other places.
So 4K, it runs on those extra CPU cores. Any other ISR, you need UCSE blades.
Okay.
Or even in a 4K, if you need more scale, you need a UCSE. So it's the same application. You can run it internally on a service container at a given scale. You need more scale, you put in a UCSE, run VWAS. You need even more scale, you put in an appliance. And part of the beauty of WAS is that rather than using just WCCP, we have AppNav under the hood, which allows you to do intelligent flow control and flow redirection. So we can actually utilize all of those different caching mechanisms in just a single pool, and it keeps track of where every flow is going and who has the spare capacity between all of those as well.
Okay. Does anybody else have any other questions?
Yeah. Well,
sure.
So we talked a lot about smart caching. Is, from your perspective, are you doing anything other than caching? Is there anything, or is this just handed back to the Cisco device to do? So is there anything in terms of accelerating that content over the WAN to go and get it from the source, right? If it's an internal application, are we doing any WAN acceleration as part of that, or is that not part of what you're interested in?
So the beauty of it is you would take advantage of all the core capabilities that WAS offers today, and we're just adding this extra feature of HTTP. They definitely work in conjunction. So you raise an excellent question. One of the new things that you can do with this is you can have a single-sided deployment on WAS, but it only does HTTP caching. So in that scenario, you'd only be using this. In a dual-sided scenario, you can take full advantage of all of the capabilities of WAS.
I think I know the answer, but just to be on the safe side. Do you do any things like optimizing session pipelining and all that stuff? So if I already have a session to the web server for another client and the request comes in, can I reuse that TCP session so that I don't spend the initial round trip times connecting to the server?
It's more based on the HTTP content and sessions. That's getting more into the core Akamai business of how we handle that, which we could, but that's not why we're here today. So if it comes down to this: if the objects are in cache, it doesn't have to go to the internet. If they are not, then we go back to we try to go back to origin or the Akamai platform.